Well, hi, good morning. Thank you for joining me here in my shop. Today is July 28th. The weather's changing a bit for it's getting a little hotter outside. It's going to be up to 30 today, which is warm, which is not unusual. It's not outrageous by any means. It's a nice summer's day, 30 degrees and sunny. So I got into my shop here this morning quite late, so I'm not going to do too much today. I think what I might focus on today is a little bit around safety. There's a couple of capacitors in here that I should probably change just for the sake of safety. Now, this is one of them right here. This one is soldered right to the chassis here. And this is another one. This one is connected to the ground terminal leading the radio. So from outside you can contact this terminal. And you'll be attaching your antenna and whatnot. Exactly where this capacitor is going, let's take a look. This one too on the schematic. So it should be easy to find. I've already found one of them. So this is the one that's going to the chassis here. And when I look at this value, I see 0.082. That's weird. Don't know what 8.2. What's the precision here? So when I can't read the capacitor as it sits right now. I have to cut it out and take a look at it, see what its real value is. So that's one. And if this one were terribly leaky, then touching the chassis is as good as touching B minus, and that could be exciting. We don't want that kind of excitement. So the other one is on the ground terminal for the antenna. That's going to be over here. Ground terminal for the antenna. Here we are. Here it is, right here. This one, 0.01. So those two, I think, need to be changed from a safety point of view. Chances are they're not dangerous. They're not leaking so much. But how do you know? You can't know. You can't know until you cut them out and test them. So let's go after this one, the 0.082. What? Okay, cut this guy out here. Now, if you haven't done this a lot, warning, soldering onto a chassis is very difficult with small soldering iron. So what I do, rather than try to solder back onto this, I'm going to cut this and leave a bit of lead wire that I can solder to easily. That would be the idea. And it's a very awkward connection down there, but I don't have to make this connection there. Anywhere I can find B minus, I should be able to connect. This is a 600 volt 0.082. Why the precision? Oh my gosh. I don't have something at 0.082. Why? This is a nice looking capacitor. Let's give it a test and see what I pulled out here. Okay. Not okay. Maybe not okay. You never know. Never know till you try. Okay, so we're looking for leaks with this machine. Although I can read capacitance with it. Okay, making sure I've got contact. You know, there can be wax on the wires here. It can be a little tricky to get a good contact. Okay, so watching the pi and its behavior. Here we go. Well, you know, it opened up halfway, so not the worst capacitor, but I'm sure if I put this to 150, it won't open at all. So this is just a quality check. It's not a quantifiable. It's not a there's no quantity involved in this test, really. So on a comparative basis, this is not the worst capacitor in the world, but it's bad enough that it should be changed out, especially considering where it's located. It's there to protect people by restricting current, I believe. I mean, it's also there for other reasons. It's there for electronic reasons for the radio to silence trouble that might occur with the chassis just floating here if we left it floating. 0.08. Why would it be so precise? 0.08. So 0.082 would be closest to 0.08. I don't even have any of those. Uh-oh. Gotta go looking. Well, I found these. Whole bag of them. 0.0082. I wonder, is 82 one of those standard numbers like you have with resistors? Maybe it's a standard capacitor number. I've never seen it. I don't know. 82. 0.08 would do the trick, but I haven't found one of those yet either. Okay, so I put in 2.04 capacitors here to get 0.08. So that's done. So now this guy's next here. And I'll leave wire here again. .027. That's different than what we saw in the schematic, isn't it? You know, these don't really matter. I could have put a 0.01 in here, I'm sure. It would just be fine. 0.027. That's like a 0.03. Okay, I think I have some of those. Right there. Okay, I'll put in the 0.03. Oh, let's test this. Tester's still on over here. If a capacitor is leaky, it's not much use in trying to measure its capacitance because the result won't be true. The capacitor checkers I have, as the capacitor becomes more leaky, tend to test it higher and higher as if it's getting better and better, and I don't think that can happen. Okay, 50 volts. What does the eye say? It says goodbye to this one. Very typical. A brand new capacitor, let me reassure you, I could put this all the way up to 450 volts, and when I hit the switch, the eye would pop back open immediately. So, I mean, this really is indicating trouble in these capacitors. There's no question. Occasionally I test the tester. There's really no reason to. Okay, so I'm going to put this guy in. And then we're going to test the radio just to be sure it works, although I'd be really surprised if somehow I damaged it. You never know. With both of these capacitors, I've chosen alternate points to connect them to back to B-. Generally not a good idea in these radios to relocate components. You have to be very thoughtful if you're going to do that. I don't think it's going to have any bearing on the radio. But you never know. Once again, you never know. You're going to get some funny sound going on in it. Maybe if you've done 4 or 5 changes and you've moved things around a little bit, you turn the radio on, it does something funny. Wow. You're going to figure that out? I don't know. I don't know. Okay, we want to hook this up to an antenna here. Go. Okay, ready to give them a try. Volume's down. Power on. Tubes are lighting, of course. I've got this bulb unscrewed. Maybe I should screw it back in just to keep me. No, I'll keep it off. It's too bright for the camera. Well, that would appear to be working. And I think we're listening to shortwave right now. Maybe not.
President Trump is some kind of diabolical monster, which they always do and they've always done. They're going to undermine our political process. They'll go after the Supreme Court, continue with lawsuits. Il y a un groupe qui réside à proximité, mais qui loue collectivement une chambre d'hôtel.
This is a broadcast, I believe. Yep, this is definitely broadcast. That's good reception. This is Hamilton we're listening to.
Because these are better, because the old whistles I don't think work. But this one, you just carry in your hand when you're going out to your car, and say a guy, okay, here's what happens, right? A guy, what? Look, say a guy bothers you, say...
Okay. Well, that's good. That's about all you really need to do. But we should do one more thing while we have it operating, and that is, while we're doing this, is that look at the set point of the pointer. The first step in the alignment is to make sure the pointer's in the right place on the string. So it's supposed to line up, I think, with the register point here. Let's just see what happens. You see it goes by ever so slightly. That's not much. It should be stopping there. It's not much. There's some kind of, looks like tape in here. Somebody tried to tape this. Yeah, somebody's put tape on the string here to try to get it to lock in tighter. So, wow, should I try taking that off? Looks like friction tape. That's going to be tough to get off. String, why would I bother? Don't bother. Now, why is it that they needed to do this? I think the string is done wrong. I think it should come over the top of these two and in behind this one, and it's done the other way around. Now, can I do this? I mean, the fact they put some tape in here indicates probably the string wasn't clamped correctly, and it looks like it's not. So I'm going to try to lift it up over top of this pointer here, this way. Okay, let's put it in the right position now. Well, not there. About there. And we would the string with this tape on it go around behind. This is where you break the string. Oh, don't say that. You just move the pointer. Think about what you're doing. Think about what you're doing. Bring on the fish knife. Oh yeah, that's good. A knife with the string. No, that's not a good idea. Put away the fish knife. Bring on a nice flat piece of metal that won't damage anything. Well, you know what? Maybe this screwdriver. Let's do it. Go down. I need another hand. Tape not helping. Okay, got it behind. Let's get it in the right position before I put the next part in. So we are at the end. Looks like it's in the correct spot. Hard to move even now. I don't know why. Okay, that's the spot. Let's see if we can get the string into the next. Tape not helping. Tape is not helping, man. Think about it. The tape has to be standing upwards. It has to be up, facing up. Looks like there's a ridge here to keep the string from sliding up. So I just got it over that ridge. Go down. Right about here the string breaks. All this sharp edged metal here. I want to go down. What's holding it up? There's a ridge on the back of this piece, I bet. And I gotta get over that ridge. Oh boy. Yeah, I should have left it alone. Well, the ridge here, the catch ridge, is at the same height as these things. So I guess the idea is the string can't come over top of this height, can't come over top of these heights. So it's probably okay the way it is. And it'd be stupid to keep playing around with it, because I'm going to break it. Did you just not hear yourself? Okay. I'm arguing with myself here, having a fight. Interesting. It says over here the word start. I probably registered it at the wrong end. That's probably what I've just done. But, looks good right here. If it's off, it's only off a fraction. Okay, leave that alone. Leave that alone. There we go. So the radio appears to be working good. Go up on a shortwave band.
To the Sanhedrin, which was the highest court in Israel. Where do you stand in this
Sounds like the same.
Do you stand with Christ?
Same one again.
Are you faithfully?
Do you stand with Christ? I thought he was sitting. Okay, there's no question the radio's working. Okay, no good. No good. Very good. Very good. Okay, that's it for today. I'm going to get outside and enjoy the beautiful day and carry on with this tomorrow. I guess it's ready now to be aligned. I think that's really where we're at with this radio. I don't think I want to change any more of those capacitors under there for reasons. Okay, thanks a lot for watching, and see you tomorrow.